So this is going to be a screencast of our roller coaster data. And what you're going to do is you're going to make a spreadsheet that will check all your work that you've done by hand with the calculator. All right, so what you'll need to do is you'll need to set up your data table in the spreadsheet. It's not imperative that you do it in the same cells I do, but I started in B3. And you're going to go along here and put position, height, don't forget your units, meters, time in seconds, distance traveled. Now, if you can't see all of it, you just come up where the arrow is and double click, and it'll make the column wide enough to show it all. I can do the same right over here on acceleration due to gravity. And so you're going to have your distance traveled in meters and your velocity in meters per second. Now, do not calculate your velocity. You're going to want the spreadsheet to do that so you can check your data from earlier and your math. So what you'll do is you'll put in your heights, you'll put in your times, and then you'll get to your distance traveled. Now, you only have to put it in once. You can click on the cell, make it a plus sign, drag down, and it will populate it with the same number over and over again. Now you can do the same thing with the mass of the ball and the acceleration due to gravity. This probably should be in grams. I should say that it's in grams. And I should say that this is meters per second squared. That again, and it'll fill that out. Now I have another graph down here at the bottom, which is, another data table down at the bottom, which is the data table you have on your sheet, and we'll get to that in a second. So now we got to tell the spreadsheet to do this calculation. Remember, velocity is the distance that the marble traveled, which is its width, divided by the time that it took. So we're going to tell it it's a calculation. So we do the equal sign. We want to take this value and divide it by this value, and we hit return, and that'll give us our answer. And then we can use that to check to see that we got that in our lab. Then you can make a plus sign, drag it down, and it will automatically, you notice it changes the cells to E5 and D5 like we need, and then it'll change this one to E6 and D6, etc. So these are our speeds. You want to make sure that those speeds make sense. This is at position 3, which is at the bottom of a hill, so it's going fast there. That does make sense. And here at the very end of the ramp, it's going the fastest, and that makes sense. So now we've calculated that. We're ready to go and calculate our kinetic energy and our potential energy. Remember that the equation for kinetic energy is 1/2 mass times velocity squared. So that's what we're going to have our calculation do. So we're going to hit in here equals, and we're going to have 0.5 for 1/2, and we're going to multiply times the mass. And what I'm going to do here is I'm going to come up here and select this cell for the mass of the ball, which is 5.4 grams. Then we're going to multiply that, which is the shift 8 key, times the velocity squared. So now what I'm going to need to do is put some parentheses, tell it to do cell F4, close parentheses, and then the way I do a exponent of 2 is I hit the shift 6 key, which is that little guy. I don't know what that's called, but somebody look that up and find out. And then 2 to square it. And now it has done the calculation, and I can hit enter. So when you look at this up here, it's 1/2 times the mass, which is 5.4 grams, times the velocity, which is 0.25 squared. And that's the calculation that it's doing. So now that we've done that once, we can just drag it down and it will do that calculation for all of them. And once again, it'll change. That's why we did the 5.4s over and over again, so that it would automatically change over. And you'll want to check these answers with the ones that you have on your graph, or excuse me, on your lab. Now, one thing that makes it a little easier, let's go ahead and round to the 100th. So we're going to decrease the decimal points down to the 100th. All right. So now we're going to do the calculation for potential energy. Same kind of deal. We're going to tell the equation for that is potential energy equals mgh, mass times gravity times height. So we're going to hit our equal sign, and our mass is going to be this cell right here, H4, and I'm going to go times g, which is the acceleration due to gravity here, times the height, and here is our height for position 1. And now we hit enter, and lo and behold, it gives us the right answer. Isn't that nice? Now we just drag that all the way down, and we have the potential energies. Once again, let's decrease that down to the 100th. And once again, you need to check these with what you have on your lab. Then let's go ahead, just for the heck of it, let's go ahead and sum them up. So here, that's a simple function. You come to function sum, and you're going to add these two cells together. And then once you've done that in that cell, you can tell it to do it in all the other cells. And that'll be a bit that we'll talk about. And now you're ready to make the graph. So real simply, we're going to select our data. You guys already know how to do this, but might as well show you. And now we're going to hit our graph button. And we don't want a bar graph. We want a smooth line graph. So we click on that. Look at that. Isn't that awesome? There we have the kinetic energy increasing, then decreasing, and then we have the inverse, right, of the potential energy, exactly what you'd expect to have. As one increases, the other decreases, and vice versa. We're going to move that to our own chart, move to own sheet, and then you need to go in, give it the effect of the IV on the DV on your title. You need to label, this one's done for you, position. There is no unit for that, but you do need to label the y-axis and make sure you have the proper unit in parentheses. And then you're all finished.